Uh,
Yes.
so,
Yes.
like you're gonna do question also right now, like along with reading a
Yes.
chapter.
First, I will do enzyme topic
Huh.
and then questions of this chapter from the enzyme.
Okay.
Then topic wise we'll do. So we know most of enzyme are protein. Some enzyme are nucleic acid. Which nucleic acid? RNA nucleic acid. And these RNA can act as enzyme like ribose enzyme, very popular. This ribozyme is present in bacteria. This is 23 srRNA, correct? Very popular, given in the molecular basis of inheritance. 23 srRNA. We can depict an enzyme by line diagram. This question can be asked. You can depict by line diagram. They can give key, you can depict the enzyme by this, only line diagram. Enzyme, like any protein, has primary structure, and primary structure tell you the sequence of inside the protein. See what is the first amino acid, second, third, fourth, fifth. That is the sequence of the amino acid in the enzyme. Enzyme have secondary and tertiary structure as well. So primary, secondary, tertiary structure, minimum three structure are present. Why? Because we know if any protein want to have biological activity, minimum tertiary structure should be there. Okay. So backbone of the protein chain fold upon itself, because you know in case of primary structure it will be like straight chain. This is primary. Secondary, there is folding. Tertiary, more folding. Correct. So backbone of the protein will fold itself and the chain crisscross itself, mix with itself and make many services. Question can be asked, how many services are there? Cervix are there, one or multiple? Multiple. Why? Multiple pocket. How do you know? See, this is 1, 2, 3, 4, 5, 6, right? Overall, tertiary structure will make active site. That we're going to talk now. One such pocket among many cervix, among many pocket, one pocket is active site. Active site is the cervix or pocket where substrate will bind. You know about this. This is active site, and only on the active site of the enzyme, your substrate will bind and it will form product. So, enzyme through the active site catalyze reaction at high rate. Enzyme catalysts are different from the inorganic catalyst. How enzyme are different from the inorganic catalyst? Inorganic catalyst can act at very high temperature, very high temperature. But enzyme act at optimum temperature, a fixed temperature. Correct. So one major difference is inorganic catalyst can act efficiently at high temperature and high pressure. High temperature and high pressure. Enzyme damage at high temperature and pressure more than 40. This number is important. More than 40. Above 40. Okay. Enzyme isolated from the organism who normally live under the extremely high temperature like hot vent and sulfur spring are stable. We are talking about Thermus aquaticus bacteria. We are talking about Thermus aquaticus bacteria. Thermus aquaticus can live up to 80-90 degree Celsius. Right? 80-90 degree Celsius. Even more than 90 degree, because in denaturation process of PCR, we need these enzymes and their temperature is 94. So it can go up to 100 also. So such Thermus aquaticus bacteria, which we use in PCR, live in the hot vent and sulfur spring where temperature is very high. Correct? And this thermal stability is very important quality of the enzyme obtained from the thermophilic organism, because these enzymes can live at very high temperature. They are stable in high temperature. We can use them. Example, You want to use DNA polymerase enzyme for DNA multiplication, but at high temperature, no enzyme is active. They will lose their property. So what will happen? You can't use enzyme, but in this situation, uh, Thermus aquaticus bacteria have tag polymerase enzyme. This enzyme active at even 100 degrees Celsius, so you can use it. Understood? Next, there are two type of change in the chemical compound. One is the physical change. What do you mean by physical change? Change in the shape without breaking the bond. Physical process, correct? And another physical process, like all these are the example, doesn't matter. Ki ice into water, water into vapor. Don't worry, you don't need to remember this. And second is chemical change when bond broken and new bond form. That is chemical change. So two type of change happen in compound: chemical and physical. Correct. So, but we don't need to remember any of this. Like how stars convert into glucose, we already know in another chapter. This is organic reaction. Correct. You already know from the chemical kinetic the rate of physical or chemical process depend upon how much product is formed in per unit time. Correct. Or how much reactant reduce, because all these things are given in chemical kinetic chapter. Correct. Rate means speed. If we know the direction, it will become velocity. Correct. Rate is speed, but if you know the direction, it will become velocity. Correct. What are the factors that affect rate? Temperature is one of the biggest factor. Example, rate will become double or decrease by half if you increase temperature by 10 degrees Celsius. Arrhenius equation from chemical kinetic tell us exactly same thing. Correct? Key rate will become double or half if you change 10 degrees Celsius in any direction. Correct? In catalyzed reaction, speed is very, very, very high. Correct? Very high means thousand of time. Example, in this process, CO2 react with the water, carbonic in presence of carbonic anhydrase, carbonic acid form. Anvita, tell me where this carbonic anhydrase enzyme present.
So I can't remember. Mm,
RBC. In RBC contain maximum amount of carbonic anhydrase. Small amount in plasma as well, but mostly RBC. Sahil Sharma. Sahil Sharma,
यस सर।
जो मेन CO2 है, ज्यादातर CO2 किस फॉर्म में ट्रांसपोर्ट होती है और कौन कौन सी फॉर्म में होती है, सारे बता दो कितने परसेंटेज।
सर एक बार क्वेश्चन रिपीट करना।
कि जो CO2 का ट्रांसपोर्टेशन होता है उसका परसेंटेज डिस्ट्रीब्यूशन क्या है, कितने परसेंट किस फॉर्म में ट्रांसपोर्ट होती है।
सर 70 to 80% तो आयंस की फॉर्म में होती है
70% बाइकार्बोनेट की फॉर्म में होती है, और बताओ।
और सर 20% के आसपास हीमोग्लोबिन होती है।
20% हीमोग्लोबिन की फॉर्म में होती है। जब CO2 हीमोग्लोबिन के साथ रिएक्ट करता है तो उसको क्या बोलते हैं। 20 to 25 NCERT लिखती है 20 to 25% of CO2 is transported with the help of hemoglobin. So when CO2 react with the hemoglobin, what is the name of that compound?
So, कोई आंसर?
Yes,
Carbamine hemoglobin.
carbamino hemoglobin.
Hemoglobin.
Because people think कि CO2 means carboxy, hemoglobin is hemoglobin, it is carboxy hemoglobin. It's not.
Carboxy is for carbon
Carbon
monoxide.
monoxide. Yes, carbon monoxide with hemoglobin is known as carboxyhemoglobin. Why? Because when you add CO2 in hemoglobin, amine group is also associated. That's why carbamina. Okay. So we will keep on adding other topic. Why? Because boring otherwise biology if I talk about only this NCERT. Okay.
I switched off my video for like 5-6 minutes. I'll just eat my breakfast and listen to you.
Sure. No issue. No. So in absence of enzyme, reaction is very slow and 200 molecule in 1 hour. 200 molecule 1 hour. Correct? By using enzyme carbonic anhydrase, 6 lakh molecule per second. 200 per hour without enzyme and 6 lakh per second. Correct? So reaction speed will be accelerated by 1 crore time. 10 million time means 1 crore time. That is the benefit of the enzyme. See, a reaction will increase 1 crore time. Correct? We have many type of enzyme and ev- like every enzyme have specific substrate. Correct? Most of the reaction is the multi-step reaction. Example, Sarah, can you tell me all the 10 step of glycolysis process?
No, sir, I'm not sure.
Anybody who can tell me all the 10 step of glycolysis?
So I can try.
Okay,
Mm.
try.
First, glucose to glucose 6 phosphate. Then,
Glucose to glucose 6 phosphate.
then glucose 6 phosphate to glucose 6 bisphosphate. I think.
Glucose 6 phosphate to fructose 6 phosphate.
Oh, sorry, sure. Yeah, my bad.
Mm,
Um. Uh. Wait. I know. Mm. Yeah, 1,6 bisphosphate. Yes.
right. So ATP used here, ATP used here because extra phosphate is added. So then,
So only twice we use ATP, right?
yes, 2 times here and here. Then phospho 1,6 phosphate
Then
convert into
glycerin. So glyceraldehyde 3 phosphate.
phospho
Basically PGA.
glyceraldehyde.
P,
Phosphoglyceraldehyde.
uh,
Correct? Phosphoglyceraldehyde 2 molecule. Because dihydroxy acetone phosphate is also formed, which is in equilibrium.
yes, sure. Then BGPA, I think. BPGA, that one, I think.
Bis phosphoglycerol
Glycerate, bisphosphoglycerate.
glyceric acid. Yeah. So
Hmm.
here you will produce NADH 2 molecule.
Yes, sir.
Give me 1 minute and note down what I wrote. So guys, from BPGA, phosphoglyceraldehyde, then
The PG.
you will remove 2 ATP. So it will be a PGA, phosphoglycerate or glyceric acid. Correct? 3 phosphoglycerate. So 3 phosphoglycerate will convert into 2
Two
phosphoglycerate.
phosphoglycerate.
Correct? 2 phosphoglycerate will convert into phosphoenol pyruvate by removal of H2O.
Yes.
And phosphoenol pyruvate finally convert into pyruvic acid by removal of 2 ATP. So remember guys, you have exam after 1 month. You should know where ATP produced, where NADH produced, where ATP consumed. Correct? Where ATP consumed. So if you see net result, ATP used 2, ATP produced 4, net ATP 4 produced, 2 used, net is 2 ATP. And net
So I'll be back in 2
NADH,
minutes.
okay, net NADH 2, done. This is the summary of glycolysis. We did important part. HK means hexokinase enzyme. This whole cycle is known as glycolysis process because glucose will break down. Glyco means glucose, lysis means breakdown. It is also known as EMP pathway, Emden, Meyerhof, and Parnas. And this whole pathway occur in cytoplasm, cell cytoplasm. Done. Tell me how much time it takes to revise glycolysis. Yes or no, guys? That now what we are talking here is explain. Every enzyme have specific substrate, like multi-step reaction. Each step will be catalyzed by the same enzyme complex or different enzyme complex. This is important question.
So could you just show the steps again, sir? I'll take a
Take
screenshot.
screenshot and then write. HK stand for hexokinase enzyme.
Done, sir.
Okay. Example here, glucose 6-phosphate convert into fructose 6-phosphate. It will be isomerase enzyme because both are isomer. Okay. Metabolic pathway. So one glucose produce 2 pyruvic acid. You know this. Correct. So there are 10 different reactions. Total 10 reactions. Correct. And if there are additional reactions, you know you can produce different product. Example, you can see here. Additional reaction, 2 pyruvic acid is the common thing. But if it present in the muscle, fermentation will happen and lactic acid will produce. In case of yeast, fermentation will happen, ethanol and CO2 produce. In aerobic situation, CO2, H2O and energy. So what we are trying to say, even there is a small change, small chemical change, but product will be completely different. Correct? Product will be completely different. Any doubt? So chemical or metabolic conversion is known as reaction. Either chemical change or metabolic change. Metabolic change is again chemical change. Correct? You know what is substrate. Reactant is substrate. Protein with 3D structure. 3D structure means tertiary structure. They have active site. Secondary structure do not have active site. Primary structure do not have active site. Active site will react with the substrate and convert into product. That's why substrate convert into product. Now we know this substrate will bind with the enzyme at active site. Substrate bind with the enzyme at active site within a given pocket, because enzyme have multiple pockets. Enzyme have multiple pockets. Substrate, this statement is extremely important, and tell me how many of you notice this. Substrate has to diffuse toward the active site. Now, why I mark this? Tell me how many of you notice that statement. Substrate diffuse toward the enzyme, and they give the opposite statement. Enzyme diffuse toward the substrate. Will you be confused, or you're like, easy hai, kar lenge? Were you 100% sure about this statement? Tell me how many of you were aware about this sentence properly. Raise your hand. Substrate move toward the one person. Jordan, okay. Bubbly, two. Okay, good. Is substrate move toward the enzyme, not ulta. So two people. You can feel ki how we make difference. Substrate has to diffuse toward the active site, not ulta. Correct? Then there is thus obligatory formation. Obligatory word is important of enzyme substrate complex. E stand for enzyme complex is transient. You know this word. Means it will happen only for the short interval. Correct? And there will be transition state structure. After bond breaking and making, product will be released. Or we can say, in this case, our substrate will convert into the product. Correct? And this undergo the transition state structure. And you can see transition state diagram in diagram. Transition state structure where substrate first go to the higher energy level, transition state, and then convert into the product. Correct? Example. In this case, substrate have high energy and product have low energy. Substrate high, product low. Difference between their energy is negative. Delta H is negative. How do we know? Example, substrate energy is high. Let's take uh, it have 100 joule energy. And what is the product energy? Less. Let's take 20 joule. What is the difference in the energy? 80 joule. 80 joule will be released in this process. So delta H will be negative, which is a good thing. If any process release energy, it is good thing. If process require energy, it is bad thing. Example, if you take ulta, substrate convert into product. You know product is having high energy. Product is having high energy. So if product is having high energy, then you know delta H is positive. We need energy. And wherever we have to invest energy, it is bad thing. Second, very basic. Activation energy is usually high without enzyme. And with enzyme, what is the role of enzyme? Reduce activation energy. You know that part. Right? The role of enzyme is to reduce activation energy. Very popular question. Reduce activation energy. Very popular question. What is the spontaneous reaction? Spontaneous reaction happen easily with minimum effort. Non-spontaneous reaction, you have to put external force, lot of external force. So we prefer in nature spontaneous reaction. Okay. This sentence is important. There could be many more altered state structure. This is very, very, very important. We don't have only one altered structural state, but many. Between substrate and product, we have Many form in between, many. Correct? And all other intermediate structure are unstable. You know that. But remember, many altered form. Stability depend upon the energy. More energy, less stability. Less energy, more stability. So, Sarah, out of substrate and product, which one is more stable?
The product.
How do you know? Correct. Answer is
So less energy.
yeah. Less energy, more stability. So, product is more stable. Correct. Next. So, based on the look of the graph, you can tell. Next, you should know what is x-axis and y-axis. In y-axis, you have potential energy. Correct. In x-axis, there is progress of the reaction, how it is going. So you should know what is present in x-axis, y-axis, energy and progress of the reaction. So in this case, we check how structural transformation progress occur, how transition state situation occur. Correct. Energy difference P is lower than S, so it is a exothermic process. Exothermic process. That's why I wrote delta H negative. Delta H negative. So we don't need to supply energy. Automatically product will form, which is a good thing. Which is a very good thing. Correct. So if process is exothermic, it will be spontaneous reaction. This will be good thing. If it is endothermic, non-spontaneous reaction, we have to invest a lot of energy. What is the purpose? No benefit. So we don't need that. Correct. Substrate go to the higher energy state, transition state. Difference between the substrate and transition state is the activation energy, as you can see. Difference between the transition state and substrate is known as activation energy. You need to activate the substrate so it can form product, right? You get up in the morning, you need some energy to get up. Then you can do work throughout the day. Correct? Enzyme eventually bring down the energy barrier by making transition state more easy. This statement is also important. What is the role of enzyme? Reduce activation energy, reduce this energy barrier, and process of conversion from substrate to product is easy. Next. Each enzyme has a substrate binding site in its molecule. Highly reactive ES is produced. Why? Unstable. Unstable things are highly reactive. Short-lived dissociate into the product. Unchanged enzyme with intermediate form, there will be the intermediate form for the product as well. For with product, you have the same form. Then catalytic cycle. This is NEET 2024 question. Exactly in sequence, they gave 4-5 points and they asked right in the sequence. First sequence, substrate will react with the enzyme, active site. Correct. Second, binding of substrate will induce the enzyme to alter shape. Enzyme shape will change. Enzyme shape will change. Why shape is changing? Because it will be tightly packed around the substrate. Enzyme will be tightly packed around the substrate. Correct. Now enzyme and substrate will be close to each other. There will be chemical bond of the substrate that will break. Correct. It will break chemical bond of the substrate and enzyme product will be formed. First, substrate bind with enzyme. Second, enzyme shape change. Substrate enzyme have tight bounding. Then chemical bond in substrate break. And finally, enzyme
So can I
product is
come back
formed.
within 5
Product will be
minutes?
released. And free enzyme is
So
sure,
yes, sir.
sure, realm. And free to bind to the another molecule. That is the catalytic cycle. Done. Now tell me,
So could you just show the 5 steps again? Sorry, the 4 steps.
Remember, all of you, don't write. Read 2-3 times. Read 2-3 times. Read 2-3 times. Next question for Brinder. Brinder, you are there? Brinder.
यस सर।
हाँ, तो जैसे हम देखते हैं रिएक्टेंट में की कोई एनर्जी होती है, प्रोडक्ट की एनर्जी है, उसके बेस पे स्टेबिलिटी है। तो एक्सोथर्मिक रिएक्शन ज्यादा स्टेबल होती हैं या एंडोथर्मिक? जैसे यही सेम टॉपिक हमने केमिकल इक्विलिब्रियम में भी पढ़ा।
सर एक्सोथर्मल।
एक्सोथर्मिक ज्यादा स्टेबल होती है। वेरी गुड। कुछ ऐसी रिएक्शन बता सकते हो जहां पे हमें एक्सोथर्मिक रिएक्शन होती है? नॉर्मली डिसोसिएशन प्रोसेस, जैसे रेस्पिरेशन की प्रोसेस है, कोई चीज टूटती है तो एनर्जी रिलीज करती है। इन मोस्ट ऑफ द डिसोसिएशन रिएक्शन और रेस्पिरेशन टॉपिक, you know it release energy, so it is exothermic process. Most of the association reaction like photosynthesis require energy, right? So it is endothermic process. Okay, next. What are the factors? Yes, Anvita.
इसमें लिखा है लास्ट पॉइंट में कि एंजाइम मतलब जब फ्री हो जाता है उससे मॉलिक्यूल से, तो लाइक वो दूसरे उससे भी बाइंड कर सकता है, तो मतलब एक ही एंजाइम बार बार कर सकता है बाइंड।
Exactly, yes. अभी ये कुछ ऐसा ही है कि हम एक बस में जा रहे हैं, ठीक है, बस में हमने बैठे, हम अपने डेस्टिनेशन में पहुंच गए, पहुंचने के बाद वो बस अब किसी और को भी लेके जा सकती, क्या दिक्कत है? So bus is one of the simplest example of enzyme. How? Because we sit there for this short interval. Correct? It reduce our time. Example, you are going to uh, Delhi to Gurgaon. By walk you will take 5 hours. By bus you will take 1 hour. What it is doing? It is reducing your energy, activation energy. So you will take less time to reach the same destination. Correct? Once you uh, get off the bus, then same bus can take off, like take another people, right?
हाँ सर।
Factor affecting the enzyme activity, affected by the multiple condition. Which structure is affected? Tertiary structure. Very, very, very important. Tertiary structure of the enzyme is affected. What are the factors? Temperature, pH, substrate, and um, binding of the specific chemical. This is also important, binding of the specific chemical that regulate activity, because we are talking about inhibitor. Okay. We are talking about inhibitor in this case. Promoter or inhibitor. Inhibitor will reduce the activity, promoter will increase activity. Correct? First is pH. Enzyme work in very narrow range. Example, if you see, if our body temperature increase by 2-3 degrees Celsius, we get fever. And we don't get like this hunger. We don't want to eat. Why? Because we know there is very narrow range where enzymes are active. Enzymes show highest activity at particular temperature known as optimum temperature. Particular pH is optimum pH. Correct? And activity will decline both after this temperature, before this temperature. Correct? In low temperature, what will happen? Enzyme will give in the inactive state temporarily. Temporarily inactive state. Preserve the enzyme. Correct? At high temperature, enzyme activity will be destroyed. Why? Heat, tertiary structure will be denatured. Sorry, protein tertiary structure will be denatured, as you can see in this diagram. Enzyme activity, if you increase optimum temperature, example from 35 to 37, activity will decrease. From 37 to 39, activity again decrease. So 37 is optimum for our body, where we get best activity, best function. Same pH. So pH and temperature graph is exactly same. Michaelis constant. See, you had same question in your exam. What it was asked ki what is Km value? Michaelis constant. So it is the concentration of substrate where speed of the reaction become half of the maximum value. Same thing was given, right, guys, in your exam. In yesterday's exam, this was there. Graph Michaelis constant. It is the amount of substrate where reaction speed is half. Correct. So why do we use this constant? Like why do we use half speed, not full speed? I wrote here mock test, 1 crore, NEET. I don't know what I wrote. But in mock test, you will get idea ki where you are going. You can never tell, no mock test can tell ki what will be the exact marks you will get in your final mark exam. कोई टेस्ट नहीं बता सकता कि कितने मार्क्स हमारे आएंगे. But mock test will give us idea. Same way, we cannot get the full speed of the reaction, but at least with the help of half, we'll get idea how much substrate we need, what could be the maximum speed, possible maximum speed based on this. So it's easy to study mock test rather than the like final situation. So next is the substrate. If you increase substrate concentration, you know speed of the reaction will increase. Correct? It will reach to the maximum value. And it will not further increase. As you can see, there is a maximum value. Saturation. Correct? Why? Because initially we have very few number of enzyme. So few enzyme, it will bind with the few substrate. Reaction speed is less. If you get saturation, all enzyme are used. No enzyme available to increase the speed of reaction. Correct? So then there is a maximum speed. Like nowadays, what could be your maximum speed? Maximum speed of the journey could be 900 kilometer per hour or 1000 kilometer per hour in plane. You cannot go faster than any plane. Make sense, guys? If you transport by cycle, bus, car, plane, these are the four, five options of the transportation. Where you can get the maximum value, plane. Maximum speed is 900, 1000. उससे तो ज्यादा नहीं हो सकती ना. Same here, saturation, because all the enzyme are used. All the enzyme are used. So enzyme are very sensitive in the presence of the specific chemical they bind to. When binding of the chemical shut off the enzyme activity, this process is known as inhibition, and chemical is known as inhibitor. Okay, chemical is known as inhibitor. When inhibitor look exactly like the substrate, it is the in its molecular structure and inhibit the activity. It is competitive inhibitor. Why? Inhibitor and substrate look same, and substrate will inhibitor will bind first. So substrate cannot bind to the enzyme, so it will close the activity. Okay. Due to the close structure similarity, as we mentioned, ki both look exactly similar. Inhibitor will compete with the substrate, and substrate cannot bind to the enzyme. That's why enzyme activity will decrease. And this is a very popular enzyme, succinic dehydrogenase. Succinic dehydrogenase enzyme activity is reduced in the presence of malonate. Why? Malonate and succinate look exactly same. Okay, just imagine you have two structure. This is I inhibitor and this is normal substrate. Both look exactly same. Inhibitor bind to the enzyme. What will happen now? This now substrate cannot bind and activity will decrease. Correct? Activity will decrease. Next question for Jordan.
No doubt. Yes.
Jordan, question. What
Yes.
is the use of succinic dehydrogenase enzyme?
It acts as a competitive inhibitor to malonate.
No,
No, it's
it
the
is
other way
not
around.
competitive. Malonate is
It's the other way around.
inhibitor.
As an
This is
inhibitor.
enzyme. What is the use of this succinic dehydrogenase enzyme?
I don't
The
remember.
complex tone, huh?
Complex 2. So what is the use in complex 2 of succinic dehydrogenase? Who will answer? There are many people, no? Rishikesh. Rishikesh.
Sir, I also don't remember.
Nirjala.
So I don't know.
Sahil Sharma.
सर जी आता नहीं है ये वाला.
Respiration implant. In Krebs cycle, succinic dehydrogenase convert succinate into fumarate, right? In Krebs cycle, succinic dehydrogenase convert succinate into fumarate. Makes sense? Where FADH is produced. FADH is produced as the name suggests succinic dehydrogenase. It means reactant will be succinate, convert into fumarate, and F for fumarate, F for FADH. So FADH will be produced in this reaction. Jordan, ask your question. Your doubt.
So I know this is a little bit out of topic, but could you explain non-competitive inhibition?
Competitive inhibition means
So non-competitive.
yeah. Competitive inhibition means when substrate and an inhibitor both look similar. So there is a competition between them. That is competitive inhibitor. In case of non-competitive inhibitor means inhibitor and substrate do not have competition. Their look is different. An inhibitor will bind to the site other than the active site.
So will this help in the formation of more product or what, sir?
No, it will not. Example, this is your enzyme. So this is your enzyme. Here you have active site, correct? Your substrate look like this, correct? But
Yes, sir.
in this situation, you have another site, another this site. Here your inhibitor can bind. This is for your inhibitor, I inhibitor. So I inhibitor will bind here. What will happen? When inhibitor bind with the enzyme shape will change like this. This is the inhibitor.
And the causal
Correct?
shape doesn't allow the actual enzyme to
Binding of the substrate. But there is no competition between the substrate and inhibitor. Inhibitor is
Okay.
binding at other site in the
Yes,
shape.
sir. So because it causes shape, a change of shape in the activation site, so you
Correct.
can't bind.
Hello. जी नमस्कार मैम. Any doubt from this? Malonate is inhibitor. Succinate is substrate. Succinate and malonate compete with each other. Malonate will bind with the enzyme, succinic dehydrogenase. and now succinic dehydrogenase will not work. You will feel ki, sir, our enzyme is not working. This must be bad thing. Correct, Nirjala? अगर एंजाइम काम ही नहीं कर रहा तो ये तो बहुत बुरी बात होगी.
Yes, sir.
अगर हम इंटेंशनली मैनिपुलेट कर रहे हैं तो ये बहुत अच्छी बात है. एग्जाम्पल, इमेजिन की सक्सिनेट एक टाइप का हार्मफुल केमिकल है हमारी बॉडी के लिए. अगर वो if it bind with the enzyme and do the harmful process in our body, cause disease, what will happen? We will be affected. Our performance will go down. To avoid this, हम क्या करेंगे? We will create a medicine. Medicine name is malonate. We will create a medicine. Medicine name is malonate. Malonate will bind to the enzyme, so harmful chemical or toxin cannot bind, and your problem is solved. Makes sense? So now tell me, all of you guys, is inhibitor good or bad?
Depends, sir.
Third, that very.
It depends if we are creating the inhibitor, it is good because we are mostly using this to prevent disease. Bacteria is producing one harmful chemical like succinate. We want to avoid this. We will produce like we will add malonate in the medicine. Medicine will be given to the patient, and person will not have bacterial infection. Make sense? Anybody have question from this? Devan's video. So Devan's इंग्लिश में कंफर्टेबल हो अगर मैं टीच करता हूँ?
Yes, sir. No issue.
ठीक है. So guys, this is done. Next is so popular कि almost in every NEET exam you get this topic. Every NEET exam. Classification, nomenclature of enzyme. Everywhere. Very popular. Classification and nomenclature of the enzyme. So enzyme have different category. Enzyme are divided into 6 class, and each class have 4 to 13 subclass. So how many class? 6. Subclass 4 to 13, and their number digit 4-digit number. Naming is according
So
to
4 to
4-digit.
13 subclasses for each of the classes, or is it
Yes, for
overall?
each classes. Each classes can have 4, 10, 5, 13, maximum 13 subclass. And you will ask, sir, what is this 4-digit number for the naming? This is the naming of the enzyme. If digit number is 1, it means oxidoreductase enzyme. If digit number start with 2, transferase enzyme. If digit number start with 3, hydrolase enzyme. If digit number is 4, lyase enzyme. 5, isomerase, and 6, ligase. And it will remain same. And you must have seen question. एक question आ गया in which you are having number 4-digit number. You don't need to take care of last 3 digit. Only first digit is important. Okay, that's why you cannot write this enzyme name in any random sequence. You should know only in the same sequence and their numbering. If first is oxidation and reduction, enzyme responsible for this is oxidoreductase. Correct? One will be oxidized, another will be reduced. No issue. Second, transferase. Transfer the molecule other than hydrogen. Why? If you transfer hydrogen, then there will be oxidation reduction other than the hydrogen. Other than the hydrogen. Why? Because if you transfer hydrogen, then it will be either oxidation or reduction. Okay. Hydrolase enzyme. Hydrolysis, as the name suggests, hydrolase, hydrolase. But question can be asked, hydrolysis of what? Hydrolysis of what? You know, hydrolysis happen in case of ester. It happen in ether. Peptide bond is formed by hydrolysis. ether bond formed by hydrolysis. Example, how? Look at this. You have two alcohol, this carbon with OH, this carbon with OH, two different molecules. We don't care about remaining three molecules. Okay. So when hydrolysis happen, water will be removed. What will be the product? Ether. Makes sense. What will be the product? Ether. So ether is formed by hydrolysis. That's what we are saying. Correct. Ester formed by the same method. Removal of water. Like carboxylic acid. Carboxylic acid react with alcohol. Correct. Water will be removed. What will form? Ester. So ester formed by the same method. Peptide we have seen in this chapter. Peptide bond always formed by the removal of water. Glycosidic bond between two glucose formed by the water removal. Carbon-carbon bond sometimes can form after the water removal. Can. Carbon halogen and carbon phosphorus nitrogen. Correct? Carbon halogen. Okay. Next. Liase enzyme. Fourth. Numbering is important. So, after completion of this topic, I will tell you to write 2 times same topic. Their numbering, enzyme name, and example. Example in case of hydrolase and ligase. Example in case of hydrolase and ligase, only 2 enzymes. Fourth, ligase. You remove the group from the substrate other than hydrolysis. Because if you do hydrolysis, then hydrolase enzyme. Other than hydrolysis, this same thing happen in dehydrohallucination reaction. Sedgwick rule. In Sedgwick rule, you remove halogen and hydrogen. Removal of HBr will form the double bond. If you remember in the hydrocarbon chapter, yesterday in chemistry discussion, we did preparation of alkyne triple bond. And in the preparation of alkyne, you use alcoholic KOH. We use alcoholic KOH for this. Very, very, very important reaction. Correct? We use alcoholic KOH. Any doubt? So to benefit, we revise the. Okay, let me ask anybody. Devans, what is dehydrohallucination reaction?
Dehydrohallucination.
Hanji. Yes.
Don't know.
Huh, Devans?
Sir, don't know.
ठीक है. So dehydrohallucination reaction, D means removal, hydro means hydrogen, and halogen, removal of hydrogen and halogen. So if you have alkyl halide, because this निर्जला नींद तो आ रही है, बस कोशिश कर रही हो कैसे जागूं. Don't worry, by 12 o'clock we'll end this session, so you'll have proper half an hour break. You can take nap for 10-15 minutes. Same with Sarah. Little bit you are drowsy, right? Huh. So this dehydrohallucination reaction given in class 12 haloalkane haloarine chapter. In the chemical property of haloalkane, it means you know your reactant will be haloalkane. When it react with alcoholic KOH, what is the role of alcoholic KOH? Not aqueous, because in alcoholic KOH you are not just removing this molecule, you are removing KBr plus H2O. Jordan, not Jordan, whom I didn't ask. Rishikesh done. Aditya, कहीं पे भी हम अगर अल्कोहल यूज करते हैं किसी भी रिएक्शन में, any reaction in full chemistry, whenever you use alcohol, what is the purpose of alcohol use? purpose of alcohol use? Aditya.
हाँ जी सर एक सेकंड
हाँ? मनन,
Yes, sir.
क्या पर्पज होता है अल्कोहल के यूज का? अगर ये समझ में
Alcohol
आ
to
गया
use.
कि एटलीस्ट 10 रिएक्शन इन ऑर्गेनिक केमिस्ट्री यू कैन इजीली कोरिलेट, वेरी इजीली.
सर वो इजीली ऑक्सीडाइज हो सकते हैं पोलर होते हैं
Oxidation और
ऑक्सीडेशन,
ऑक्सीडेशन करवाने के लिए किसी भी कंपाउंड का.
कंपाउंड ऑक्सीडेशन करते हैं.
Chemical.
सारा यू वर देयर व्हेन आई एक्सप्लेन अमाइन, एंड इन अमाइन चैप्टर आई एक्सप्लेन द सेम कॉन्सेप्ट. सारा,
Yes, sir.
you were there in the amine chapter when I explained amine thoroughly from the zero, right?
Yes, sir.
And I explained this concept in the ammonolysis topic also, and in Gabriel pathalamide also. What is the purpose of alcoholic KOH? Do you remember?
Oh. No, sir, I can't remember.
Sahil Sharma,
यस सर.
बताओ क्या पर्पज होता है अल्कोहल यूज करने का?
क्या सर?
पर्पज क्या होता है अल्कोहल यूज करने का? क्या था करा पे अल्कोहल यूज? In general, why we use alcohol in chemical reaction?
Okay.
हेलो हेलो, हाँ जी
सर उससे
हाँ जी
कीटोन वगैरह फॉर्म हो जाते हैं.
हाँ जी.
सर अल्कोहल अगर यूज करते हैं किसी केमिकल रिएक्शन में तो उससे जो रिएक्टेंट होता है वो एल्डिहाइड और कीटोन प्रोड्यूस करता है.
अल्कोहल एल्डिहाइड कीटोन
So
प्रोड्यूस
if
करता है,
it's
दैट इज
reacted
ट्रू.
like haloalkanes, it's supposed to remove the halogen group, right? K reacts with the halogen group and OH takes the H out. Dehydrohalogenation, that forms water.
ओके. हेलो हेलो, हाँ जी. हेलो तो आंसर द सिंपलेस्ट आंसर गाइस, दैट्स द प्रॉब्लम कि आई understand why you are facing issue in the subject, because you lack basic. The simplest purpose of alcohol is removal of water, dehydration. What happen when, like Jordan, you have this experience, tell me, when you consume lot of alcohol, what happen? Dehydration happen in your body.
Yes,
Exactly, that's the purpose ultimately. Why we are using alcoholic QH here? Because you can remove H2O.
I mean, I said it for what are this? Haloalkanes. Because like K
Yes,
always reacts with
example
the X
in
group. Same
example
thing.
in case of this dehydrohallucination reaction, if you have aqueous KOH, what will happen? OH will replace X.
Yes, sir.
Like in nucleophilic substitution reaction, same thing happen. OH
Yes, sir.
part replace halogen part.
Yes, sir. That's
Make
if it
sense?
happens. Yes, sir.
But what is the benefit of alcohol?
It
Dehydration.
dehydration. It forms
And
double
not
bonds.
only here, trust me, minimum 10 places in organic chemistry.
Yes.
Whenever you have word alcoholic, it means always remove water. In Gabriel pathalamide, you use alcoholic KOH. Why? You remove H2O.
So NaOH as well as KOH, both of these.
Yeah, anything you use, base you use, and you use alcoholic form, you always remove water in
Yes.
presence of alcohol, always, without exception. As simple as that. Batao, anybody have doubt? All of you are aware about this basic concept ki alcohol means removal of water, nothing else, always removal of water. Now you are understanding what is the role of basics. Now wherever you get ki alcoholic form, you don't know reaction, at least you can remove water and you can see what are the possible products. Make sense? If you understood this, come to this liase. Same thing happen here. The product will have double bond and X and Y will be removed in this case. Correct? Double bond. Like, in case of, let me just ask this question to whom? Anvita, in haloalkane haloarenes, you have seen ki if you take alkene and add halogen, like Cl2 in presence of CCl4, what will be the product?
Can you repeat, sir? You add what?
You add Cl2.
Huh?
No, no. No. So if you add Cl2 in alkene in presence of CCl4, this topic is given in the chemical reaction of haloalkane. What will be the product?
In alkene.
Yes.
I don't remember. So is this the one which we use UV light also?
This is the test of unsaturation. This is the test of unsaturation when you take any alkene and add any halogen in presence of CCl4.
विसिनल वाला होता है.
हाँ, vicinal. So reddish brown color will be colorless. Reddish brown color will be colorless. This is colorless. This is reddish brown color. Reddish brown, reddish orange color. Okay. So this convert into this. It is the test of unsaturation given in the haloalkane preparation in the vis form. What is vis? When functional group are present on this sidewise. Example, one halogen and one carbon, second halogen on the next carbon. If they are present on the same carbon, it is jam. Same carbon jam, opposite adjacent carbon vis. Anybody have question? If you do ulta, you have vis and you can make alkene. It means there will be exactly same process how liase is used. You had vis form, and when they join and produce the alkene, you almost get the same. Next, isomerase, as name suggests, isomerization. Glucose convert into fructose, you need isomerase enzyme. Glucose 6-phosphate convert into fructose 6-phosphate, isomerase enzyme. Interconversion of optical isomer, geometric isomer, or position isomer also. Like instead of second position of alcohol, it transfer to third position. What is this? Isomerization, isomerase enzyme. And last, ligase. Ligase means linking two compound together. Linking two compound together. Linking two compound together. Example, carbon and oxygen, carbon sulfur, carbon nitrogen. So carbon with basic compound, oxygen, sulfur, nitrogen, and even phosphor, because one question was asked exactly like this. So this topic is extremely important. Almost every year, same question asked. Okay. Now take your 2 minutes, note down all these 6 enzymes in the same sequence, and write example of hydrolysis, hydrolase, and ligase enzyme: carbon, oxygen, carbon, sulfur, carbon, nitrogen, and phosphorus oxygen. Note down and send me in the group. Note down all these enzymes, hydrolase, ligase, example, send me in the group, and make it fast. Write it like rough work, not. Anybody sent me? Let me check.
सर क्या भेजना है एक बार दोबारा बता दो, मैं था नहीं।
ये जो पेज पे दिख रहे हैं 6 एंजाइम, इनके नाम सेम सीक्वेंस में, और हाइड्रोलेज और लाइगेज के एग्जांपल। Make it fast.